Okay, so till now, whatever we have discussed, do you have any doubt or any confusion in that? Till now, whatever we have discussed, do you have any query or any doubt in those? But am I audible? Am I audible?
Yes, sir.
Okay, okay. So till now, what?
Okay, okay. So till
Yes.
now, what?
Do you have any doubt on that? If you have any doubt, you can ask me. Okay, so let us start the class. Okay. So next, in the last class, we have discussed about the various properties of country. Is it? So now let us move to the next part. Okay. So now we will discuss what are the different methods by which we can design the RCC structures, and also what are the advantages and disadvantages of the various methods. Okay, we will go through all of this today. Okay. So now I will share my screen. If you can see it, you just tell me, okay? If you can see the screen. Can you see the screen?
Yes, sir.
Yes, sir.
Okay, okay. Okay, so let us, in the last class, we have discussed about the characteristic strength of concrete. Okay, so now let us see characteristic strength of steel. Okay, so you can see in the PDF in that in this file, the term characteristic strength means the value below which not more than 5% of the test results are expected to fail. The definition is similar, exactly same with the concrete. Okay, so as per IS 456, the characteristic strength of steel is equal to the minimum yield stress or 0.2% of proof stress. Okay, so can anyone tell me what is the meaning of yield stress? Can anyone tell me what is the meaning of yield stress? Stress, though all of you know that what is the meaning of stress, but what is yield stress? Hmm? Can you tell me what is yield stress? Anyone? If you know what is yield stress, you just tell me. If you don't know, you just tell me. We don't know. Okay. So to me, you can't hear properly. Okay. So others, Shiroda, do you know what is yield stress? Okay, I hope no one know the answer. Okay, so now I will tell you. Okay, what is yield stress? Yield stress means it is the stress corresponding means. I think you can see the stress strain diagram for steel. I think I have shown you before also. Okay, so let me show you again. Let me show you the diagram. Okay. Okay, so can you see the screen now? Can you see the screen? Stress strain curve for reinforcement. Can you see?
Yes, sir.
Okay. So now in this figure, you can see this figure. Okay, so along y-axis we will put stress, along x-axis we will put strain. Okay, so from zero, from the starting point till this point, you can see a straight line. Is it? That means up to this point, our stress is directly proportional to strain. Okay, so and also we know that within elastic region only stress is directly proportional to strain. Is it? This is the stress strain curve for reinforcement. Reinforcement means steel. Okay. Stress strain curve for steel. That means if you put load, how the stress and strain will vary according to load, this curve will indicate that. Okay. And this is for mild steel. Okay, mild steel, in the diagram also it is mentioned. Stress strain curve for mild steel. Fe250 with definite yield point. Okay. So now in this point, in this figure, from this starting point to this point, you can see the line is straight. That means up to this point our stress is directly proportional to strain. Okay, so till this point we can say that elastic region is there. That means elastic region means if you remove the load, it will again come back to its original position. Okay, so but after that, after this position, you can see that it is bending like this. That means now it is not a straight line. Okay, so at this point whatever strain will be there, this point will be known as yield strain. That means after beyond this point whatever deformation will occur, that deformation will be permanent. Okay, and for this point whatever strain, for whatever stress you will get here along y-axis, that will be known as your yield stress. Okay, so if anyone asks you what is yield stress, so you have to say yield stress is the stress at which permanent deformation starts. Okay, yield stress is the point at which permanent deformation started. Okay, permanent deformation of steel or any metal.
Sir, sir, I double L ill.
No, yield.
Okay.
Okay, wait,
Okay, sir.
I will show that. I will let you go to the word file. Where is the word file here? Okay, see here in this word file. Where is the word file? Can you see the word file?
Sorry.
Wait. Okay, so now can you see it? I think all of you can see it. Is it?
Yes, sir.
This is yield stress. This is yield stress. See the spelling. YIELD. Okay, yield stress. Yield stress means it is the stress at which our elastic region ends and plastic region will start. Plastic region means in that region whatever deformation will be occurred, that will be permanent. Okay, if you remove the load also, then also the steel or that material will not come back to its original position. Okay, I hope all of you know elastic region. Elastic region means within elastic region, if you put load, deformation will occur. If you remove the load, it will come back to its original position. That in that region is known as elastic region. But as soon as we cross the elastic region, if you put any extra load, permanent deformation will occur. Okay, so at that point, whatever stress you will get, that will be known as yield stress. Okay, or there is another term, proof stress. Okay, so proof stress also I have written here. What is proof stress? Proof stress is the stress which is just sufficient to produce a defined amount of permanent strain which a material can have without appreciable structural damage. If you read it, I think all of you can understand. It is the stress under load. When you put the load, some stress will occur, and in the end, you can see a defined amount of permanent residual strain. That means the strain will be permanent. Whatever deformation will be occurred, it will be permanent without appreciable structural damage. That means some deformation will occur, but that damage will not be permanent. Means not very high. Okay, without appreciable amount means the deformation will be small amount, and also the damage will be small. It will not be. It will not fail. Okay, so next we can see various types of reinforcements are there. Okay, so various types of steels are there. In this subject, we will be basically dealing with mild steel and HYSD bars. Okay, mild steel, you can see in that you can read this. Mild steel bars are also known as Fe250. Okay, because the yield strength of this steel is 250 Newton per millimeter square. Okay, similar to concrete, if M20 grade of concrete is there, you will write FCK value equal to FCK equal to 20 Newton per millimeter square. For steel, what you will write, if Fe250 grade of steel is there, then you will write yield stress. Yield stress will be written by Fy. Okay, F suffix Y. Fy equal to 250 Newton per millimeter square. In terms of concrete, characteristic strength will be indicated by FCK, but in terms of in case of steel, you will write Fy, small f suffix small y. Okay, so if mild steel is given, you will write Fy equal to 250. If Fe415 is given, you will write Fy equal to 415 Newton per millimeter square. You can see mild steel, if mild steel is written, then you have to understand Fe250 grade is given. Fe250. Okay. The modulus of elasticity is given 2.2 into 10 to the power 5. In the later classes, when we will solve some numericals, you will remember these values. Okay. Now no need to remember, just see these things. Okay, so next another type of bar is high yield strength deformed bars. I think all of you have seen it during the construction. We won't use this plain bar. Okay, we will use this kind of deformed bars. Okay, you can see it, some threads are there in the steel bars. You can see a lot of threads are there. Okay, so these are deformed bars, and these bars are available in two types: hot rolled, high yield stress bar. No need to go through all of, just see the theory part. Okay, so but we will need this Fe415 and Fe500. These two we will use in this syllabus, in this subject. Okay, so if you are given Fe415 grade of steel, that means you have to understand that the yield stress for this steel is 415 Newton per millimeter square. Similarly, if you are given Fe500 grade of steel, then you have to understand that the grade of the yield stress of the steel is 500 Newton per millimeter square, and you have to write Fe Fy, okay, not Fe, Fy equal to 500 Newton per millimeter square, and for this you have to write, okay, so I will write it down here, you can see it, Fy equal to 15. Can you tell me what will be the value here for Fe 500? What will be the value of Fy? Can you tell me the value?
500.
Yes, 500. Okay. So now I think you have understood this one. If Fe2
Yes, sir.
will be given, you have to write Fy equal to Fy value will be 250. If Fe 415 will be given, Fy value will be 415. If Fe 500 is given, then you will write Fy value equal to 500 Newton per millimeter square. And what is this Fy? F means stress. This Y means yield. Okay. F for stress and Y for yield. That means yield stress is for Fe 500 grade of steel, your yield stress will be 500. For Fe 415, yield stress will be 415. And for Fe 250, Fy value will be 250 Newton per millimeter square. Okay. I hope all of you have understood this one.
Yes, sir.
Okay. So next, you have to understand this, why these HYSD bars are preferred over plain bars. Okay, so HYSD bars means these bars will have threads over them. Okay, and because of these threads you will get higher strength. How you will get higher strength? Because of these threads, the bond between steel and concrete will be better, and as a result of that you will get a higher strength. Okay, so you can see here higher strength. HYSD bars have yield strength higher than the plain mild steel bars. Similarly, next advantage is better bond. Then it is economy. The cost of HYSD bars is approximately same with mild steel, but HYSD bars leads to overall economy as the amount of steel required is less due to high strength. Okay, just 1 minute. Okay. Okay. So these are just theoretical part. You will not get any question on this. Just you have to understand what are the types of steel, what are the different grades of concrete. Okay. Okay. So next our main part will start from now. Okay. The main theoretical part will start from now onwards. Okay. So design philosophies. Design philosophies means you can see here. Design of RCC member comprises of the following. Why we need to design the RCC members means if you are going to construct a building, first you have to design the various parts. Okay, but why we need to design the various parts? There are mainly two reasons. First, to decide the size of the member and the amount of reinforcement required. Before going for the construction, first we have to know what will be the size of individual members. That means if you are going to construct a beam, you must know that what is the size, what will be the size of the required beam, what will be the size of that required column, or what will be the size of that footing. Okay, so before going for the construction, you first design everything, means what will be the dimension, and then how much amount of reinforcement will be required in those particular members. Okay, these things first you have to design, then only we can go for the construction. And the second important reason is to check whether the adopted section will perform safely and satisfactorily during the lifetime of the structure. That means after designing those members, you have to check whether whatever sections you have designed, whatever members you have designed, those members will perform safely and satisfactorily during the lifetime or not. Okay, if it is not safe, then you can't go for the construction. Okay, first you have to check briefly how whether it will perform safely and satisfactorily or not, then only you can go for the construction. Okay, so these are the main two reasons. And there is another reason, we have to estimate the cost also before going for the construction. How much it cost for the construction, you have to first find out that one also. Okay, so these are the main three reasons because of which we have to design the various members first. Okay, next let us see the various methods which are used for the design of RCC structures. Okay, so these are very important. Okay, first method was known as working stress method. Second method is known as load factor or ultimate load method. And the third method is known as limit state method. Okay, so these are the various methods by which we can design the RCC structures. Okay, so now can anyone tell me at present, if you have to go for construction, which method you will follow? Can you use all the three methods, or can we use, or should you use only one method out of these three? Now at present, if I tell you have to construct a building in Guwahati, okay, so now can you design, will you design the building based on the three methods, or will you design the building based on only one method? Can anyone tell me? Can anyone tell me which method we will follow?
Sir, one method.
Yeah, which one? Can you guess which one? Or if you know, just tell me.
Two.
Two. Okay, so is there any other answer? Okay, so Hoketo said we will go for second method. Okay, so any other answer? Anyone have any other answer? Just tell me, just guess it. Okay. If you know the answer, you tell me, or you can guess also. Your guess might be
Sir, one.
one. Okay.
One.
Okay, Dev Burma, I got your answer one. Okay, so any other answer, Shirodha? Any other answer? Do you know which method we will follow?
Three.
Which method?
Three.
Three. Why?
Because
Will use
at
huh?
present the construction methods are
Construction is based on third method, na? Limit state.
yes
I
sir.
don't know. According to you, at present, if you have to construct a building, then you will follow third method. Is it?
Yes sir.
Okay, okay. So many students are there. Do you have any other answer? Which one? Which one? I have got three answers, and all of you said first. One student said first method, second one said second method, and third one said Shirodha said third method. Do you have any other answer? Anyone have any other answer?
Two.
Two. Okay. Two. Wait. A minute. Okay, so I will tell you now. At present, if you have to construct a building in India, anywhere in India, you have to follow the third method. The first and second methods was very old, and if you go for the first and second method, it will be uneconomic and your structure will not be safe. Okay, so now I will tell you all details about all the other methods. Okay, so let us first see what is working stress method. What is working stress method? Yeah. Okay, can you see this? Can you see this working stress limits working stress method? Can you? I hope all of you can see that. Is it? We'll send the.
Yes, sir.
Yes, sir.
Okay. So working stress method. They say you can read this one. This was the traditional method of design, not only for reinforced concrete but also for structural steel and timber design. Okay. So why we are not using this method? This method was initially at first this method was developed. Okay. So if you are constructing a building in 1970s or 1980s, then we would have used this working stress method because the other two methods was not developed at that time. So we have only one method, this working stress method. So we would have used this one, working stress method. So what is the basic criteria in this method? So in this method, it was assumed that the structural member behaves as a linear elastic manner. That means it was assumed that this steel and concrete both are perfectly elastic. But as we know that these are not perfectly elastic structures. Okay, I hope all of you are getting what I am trying to say. Can you tell me that whether your steel is perfectly elastic? Yes or no? Is it perfectly elastic?
Sir.
No,
Yes or
sir.
no? Yes or no?
No.
No.
Yeah. Similarly, concrete also. Is it perfectly elastic?
No, sir.
No. But according to this working stress method, both steel and concrete are perfectly elastic. Okay. So as now we know that this is actually not true, so we uh, can't means accept this statement. Okay. So next it has you can read this one. However, the main assumption and assumption that the stresses under working loads within problem. Okay, so here in this method, it is also assumed that uh, the complete tensile stresses. Okay, the complete tensile stresses are taken by steel only. Okay, and nothing will be taken up by concrete. But is it true? I, as we know that our concrete is weak in tension, but is it true that it can't take 1%? It can't take 1% of the tensile stress also. Is it true that it can't even take 1% of the tensile stress? Is it true?
No.
No.
No,
It
sir.
will take some amount of tensile stress. Is it? It will be less,
Yeah.
but it will take some amount of tensile stress. Is it? Hello?
Yes, sir.
Yeah, we know that our concrete is weak in tension, but that doesn't means that it can't take as one. It can't take 1% of the tensile stress also. It will take very less amount of tensile stress, but it will take some amount. But according to this working stress method, it says that 100% of the tensile stress will be taken up by the steel, and none will be taken by concrete, which is not correct. Okay, so these are the various assumptions based on which this working stress method was developed, and after using this working stress method, people realize that the cost of the construction is very high and the size of the members are also very big. Okay, so because of these reasons, in later years, people think that we must develop this method, because otherwise our cost of construction will be very high, our structure will not be safe, as well as the member sizes are will be very high. Okay, so in the later years they have developed the second method, which is known as ultimate load method or load factor method. Okay, so in this load factor method you can see that this method is sometimes also referred to as load factor method. In this method, the stress condition at the here it is assumed that the not assumed, they have taken that the steel and concrete are not perfectly elastic. Okay, not perfectly elastic. Up to certain point only it will behave as a perfectly elastic material, but beyond the beyond that point, both concrete and steel will be inelastic. Okay, and they have considered a factor here in this method. They have considered a factor. The safety measure is introduced by an appropriate choice of load factor. Okay, they have introduced a factor which is known as load factor, and it is defined as the ratio of ultimate load to the working load. Okay, ultimate load means, okay, so can anyone define what do you mean by ultimate load and working load? Can you understand by the word ultimate and working? I hope all of you can understand by the term load. But what is the meaning of ultimate load and what is the meaning of working load?
Mm, don't know, sir.
Take a lot of load.
Ultimate load means?
Sir, it means it can take a lot of loads.
Okay, and working load?
Don't know, sir.
Okay, see, ultimate load means the maximum amount of load that the structure can carry. Okay, so beyond ultimate load, your structure will fail. That maximum amount of load will be known as ultimate load. Okay, and the working load is whenever you will construct something, you will not put that maximum amount of load. Is it? Yes or no? Whenever you will construct a building, you will not put maximum amount of load. Is it? Work
Sir.
means the actual amount of load which is acting on that particular member. That is your working load. And ultimate load means maximum how much load that member can carry. That is your ultimate load. Okay. So if you find out the ratio of ultimate load by working load, you will get a value. That value they will introduce as a load factor. Okay, in this method, they have divided the ultimate load by working load. They will get some value, and that value they said that this value is known as load factor. Okay, and because of this factor, we know they named the method as load factor method also, ultimate load method or load factor method. Okay, and the last method is known as limit state method. Limit state method, which is the best of these three methods, because in this method they have removed all the disadvantages of first method as well as the second method. We'll go through in details about this limit state method when we will solve numericals and everything. Okay, so limit state method will be two types of limit state methods. One will be limit state of collapse and second one will be limit state of serviceability. Okay, so limit state means it is a state of impending failure beyond which a structure ceases to perform its intended function. Limit state means, okay, so if I ask you what is the limiting value? Limiting value means maximum value. Okay, limit means maximum. Yeah, so limiting state means if a structure has reached its limit state, that means beyond that state your structure will fail. Okay, so here also it is written a limit state is a state of impending failure beyond which a structure ceases to perform its intended function satisfactorily in terms of either safety of serviceability. That means it either collapses or becomes unserviceable. That means after reaching the limit state, your structure either it will fail or it becomes unserviceable. That means you can't use that structure. Either can happen. Either it might collapse, that means your structure may fail, and it might become unserviceable. That means you may not be able to use that particular building or structure. Okay, that particular state is known as limit state. Okay, so here we have to deal with two types of limit states. One will be known as limit state of collapse or ultimate limit state, and second one will be limit state of serviceability. Okay, so limit state of collapse means it will deal with the strength, overturning, sliding, buckling, fatigue, etc. That means it will, we have to find out what will be the maximum load that your structure can carry, how much will be the maximum deflection. These things, everything we have we have to find out in limit state of collapse. But in limit state of serviceability, it will deal with the discomfort to occupancy or malfunctions. Okay, we have to see whether your structure can give you the required service or not, whether you can use the structure or not. Okay, that means it will be.
Sir, what is buckling?
Huh?
So what is buckling?
Buckling means, okay, so buckling we'll see in when we study about column, then we will see buckling. Okay, buckling means if you put load, your column will buckle, or buckle means there is another word. Buckle means cripple, means your when the column will bend after putting the load. After some years, after 50 years, you can see your column will be bending from its original position. Okay, that bending shape is known as buckling. How much buckling has occurred? Yeah, I will show you some figures when we will study columns. Then you will understand better. Yeah, buckling.
Okay.
Then serviceability means, I hope all of you know what is serviceability. Serviceability means if you design a structure, your structure must be safe and it must be serviceable. That means you must be able to use that particular building. Otherwise, if your building is safe, but if you can't use that building, will your client accept that one? If you get a client and if he said that I have to design a G plus 2-story building, so after designing the building, your building is safe, but it is not usable. Then in that case, your client, will he accept your design?
No.
No. That means whatever you will design, your building must be safe, as well as at the same time your building must be usable, or your building must be serviceable. That means the occupants who will be living in that particular building or particular structure, they must find comfort in that particular structure. Okay, then only we can say that our structure is safe as well as serviceable. Okay, these two things we have to study in limit state method. Okay, so now we will see what are the different. We will see briefly about working stress method. The second method we are not going in detail. Second method, because it is not important. We will deal with first. We have to study working stress method. We have to solve numericals on that. Next, we have to study in details about limit state method. Okay. So let us first see what is limit state method. Not limit. Let us first see what is working stress method. Okay. So we have discussed these three methods: working stress method, load factor, and limit state method in details. Next, we will see what is working stress method of design. Okay. So let us first see what are the different types of RCC beams. Okay. Our RCC beams may be singly reinforced beam, doubly reinforced beam, or singly or doubly reinforced flange beams. Okay. So now, can anyone have any idea about singly reinforced beam? Do you know anything about singly reinforced beam? Do you have any idea about singly reinforced beam?
Maybe single layer of reinforcement.
Yeah, single layer of reinforcement. In which portion you will provide that reinforcement? Tension zone or compression zone?
Yeah, tension zone, sir.
Okay, okay, good. In singly reinforced beam, we will provide reinforcement only along the tension zone. Okay, that means in a particular beam, if I give you a simply supported beam, you will provide the reinforcement at the top or at the bottom. If I give you a simply supported beam, and if the beam is singly reinforced, then you will provide reinforcement at the top or at the bottom.
Bottom, sir.
Yes, bottom, because at bottom only our tensile stresses will develop. So we'll provide the main reinforcement at the bottom. Next, what is doubly reinforced beam? The name itself says the meaning. The name itself says the meaning. What is W reinforced beam?
Double layer of beam, I guess.
Yeah, double layer of reinforcement. But at which portion we will provide the double reinforcement?
Mm. I don't know, sir.
You can guess also. You can guess that also. W reinforced means there will be two layers of steel. But in which portion we will provide those two layers? Will
Compression zone.
okay, tell me.
Compression zone.
Compression. And what about tension zone?
I don't know, sir.
Sir, both tension and compression.
Yeah, good, good, good. W reinforced beam means we will provide reinforcement both in the tension zone as well as in compression zone. Okay. So, in single reinforced beam, we will provide reinforcement only in the tension zone, but in W reinforced beam, we will provide reinforcement both in the tension zone as well as in the compression zone. Next, third one is singly or W reinforced flange beams. That means, in other words, you can write, you can say this is a T beam. Yeah. Okay, so now can anyone tell me, have you seen T beam anywhere? Have you seen T beam anywhere? In any building, if you see the construction, have you seen T beam anywhere? T beam means the shape of the beam is a T. The shape of the beam will be just like a T. Have you seen that anywhere? In every building, if you see that shape of the beam, you can see the type of the, you can see at least one T beam is there. Okay, so I hope lot of constructions are going on in your nearby place, or if the construction is complete also, then also if you see the beams in any house, then you will see the shape of the beam. It is just like the shapes will be just like T or L beam. The shape might be your T, it might be L shape. Okay, T shaped or L shaped. Okay, so if you haven't observed this one, today you see the beams in any building, then you will understand what is T beam and what is L beam. Okay, so now let us see what is singly reinforced beam. I will show you some figures. Okay, can you see the screen? I hope all of you can see the screen. Okay, so this is your singly reinforced beam. In singly reinforced, simply supported beams or slabs, reinforcing steel bars are placed near the bottom of the beam or slabs where they are most effective in resisting the tensile stresses. This is your singly reinforced beam. And this is the shape of the reinforcement. Reinforcement in a simply supported beam. That means, say this is your beam. These are the two supports. So here our neutral axis will be at the just at the center. So below the neutral axis, tension zone will be there. So we will provide the reinforcement in the bottom. So you can see here, steel reinforcement is provided here. Okay. Okay, so this figure is your top view or side view. First figure, this figure, from which side, if you see the beam, you will see this figure. From which side? From the top, from the bottom, or from the side?
Side.
Huh?
The front.
Front, yeah, front or side. Okay, if you see from the front, then you will see this figure. You can see the steel here, you can see the supports, you can see the distance. Okay, so what about this? What is this view?
Top.
This view is,
Top, sir.
yeah, this is your top view. Okay, view. If you see from the top, you will see this figure. Okay, this is your top view. So you can see this is a section also. If you cut your beam here, if you cut your beam here, if you see from this side, then you will see these reinforcements at the bottom. Okay, this is your cross section. If you cut your beam here at the center, and if you see from this side, then you will see this figure. So this is our cross section. If the width of the beam is B, if the depth is D, and okay, so what is this capital D and what is this small d? Can anyone guess what is this capital D and what is this small d?
So white.
B is the width of the beam. Okay, B is the width of the beam. But what is this capital D and what is this small d? Hmm? Yeah, capital D is the total depth. That means overall depth from the top to the bottom. This is your overall depth. Capital D means your overall depth from the top to the bottom. But what is this small d? Can anyone guess what is this small d?
Distance between the top layer and the part where reinforcements provided.
Yeah, it is the distance from the topmost layer, top, to the center of the reinforcement. Okay, it is the distance between from the top to the center of the reinforcement. And this small d is known as, can you tell me the name?